this question here, we're looking at angle of depression in a scenario that involves buildings and a utility pole. Okay. So from the roof of a building, the angles of depression of the top and bottom of a 10-meter utility pole are 33 and 52 degrees. So 33 and 52 angles of depression. Find the height of the building. Okay, that's a little bit confusing. So let me start kind of, sketching this out to see what it looks like. I have my building here. Let's write it in like this. And there we go. And the utility pole, let's say it's over here. And I'm looking from the top. So let's say I'm looking from the corner down to the bottom here and to the top here. Let me try that again. There we go. Now keep in mind that everything is measured relative to the horizontal. Okay, so the top of the utility pole to this point here, okay, this is going to be 33 degrees. And to the bottom of the utility pole, this larger angle here, this is what's going to be 52 degrees. Okay, so we have these angles in here and can't quite identify a right angle triangle yet, but look at if I do this. If I extend this, let's say I were to extend this value here. Okay, I know that utility pole is 10, and I'm going to call this here x. Well, if I can figure out what x is, well, x plus 10, whatever that's going to be, is going to be that height, and that height is just the height of the building. Okay, so that's going to help me. But let me take that out, and I'm going to probably have to introduce a new variable, so I'm going to put a y over here. And let me set up my equations. So I'm using opposite and adjacent. You can see this as like two triangles kind of, upside down. You have this one here, okay, this guy. Then you have this bigger one, which is this guy, upside down, but nonetheless, they are right angle triangles. Okay, so I'm going to erase that. And let's set up our equation. So I have tan of 33 degrees. That's going to give me x over y. And then I have tan of 52 degrees. That's going to give me x plus 10 over y. And I'm going to rearrange these equations in such a way that I can solve for one of the variables. So I think isolating for x. So I'm going to have here x equals y tan 33, and over here I'm going to get x equals y tan 52 degrees minus 10. Again, I did a whole bunch of steps in that in there, so please make sure you understand what they were. But the good thing is that they're both equal to x now, and I can equate them to each other. So I'm going to copy this guy and paste him over here. And same thing with this side. I'm going to copy him and paste over here. And I know because they're both equal to x, they're equal to each other. I don't need this, and I don't need this. And I think we're good. The nice thing is that I only have y by itself. So let me rearrange this equation in such a way that y is isolated. So I'm going to copy all of this, paste it here. Oops, that's not the right one. Copy all of this guy here, paste over here, and that plus 10, because it goes over to the other side, will become positive. And I'm left with y tan of 52 degrees. Final step, divide both sides by tan of 52. Tan of 52, tan of 52 degrees. So cancel, cancel. And now it's time for all this calculation to do. So I'm going to pull up my calculator once again and do the work. Okay, let's see here. So numerator, I'll put that in brackets. I got 31 tangent minus 33 tangent plus 10, and I'm going to close those brackets, and that's all divided by 52 tangent, and that equals 7.77. Let's just say 7.8. So y is equal to 7.8. Remember, we wanted to find x, so I'm going to have to plug that into one of the equations. Okay, it can be either this one up here or this one up here because they're both, you know, x's in terms of y. I'll use the first one because it's just one calculation. So whatever that number was times 33 tangent gives me 5.04. So my x value, let's just zoom out here. So I'm going to get my x value is equal to 5.04 meters. And there we have it. The height of the building is not 5.04, but 15.04 meters, because again, we have to add that 10 in.